Hello there, AV here! Welcome to the first CPU cooler review on the AV Techie channel, which is of course about the Cooler Master Hyper 212 Evo. Now, long-term viewers of this channel will know that I've used this in every single air-cooled build I've done, testing all the different cases that I've done reviews of. You can check all those videos out in the top right-hand corner playlist. First things first, we're going to unbox it and check out all it has to offer inside. Then we're going to mount it onto the motherboard and we'll test it with a single fan it has. That will be our standard thermal test. Then we're going to do a maximum thermal test by replacing that single fan with two EK Varda 2200 RPM fans. We'll then compare those two results and see what the difference is between the included single fan and two high performance fans. So we're going to go straight into it. We'll do the unboxing. I hope you enjoyed the video. If you do, please give it a like. If you don't, please dislike it and let me know where I'm going wrong. And if you have any comments or suggestions, then let me know in the comments below and I will catch you in a second for some commentary about the unboxing. So this is the part where I could try and pretend that I have all the packaging retained from the first time I opened this box many years ago. But nothing has changed in its design since. Everything you see here is what you'd get if you bought them from the store today, and all I'm missing is the plastic shell. Anyway, following the worst unboxing experience I could possibly manage, we'll take a look at the accessories later, but let's get on to the star of the show. The Hyper 212 Evo is what I would call an above average size cooler, standing at 159mm tall, 120mm wide and 80mm thick. She's not exactly small, but remains compatible with most ATX and micro ATX cases. Up top is what you'll see most of the time if you get this cooler, which is where the heat pipes terminate. They aren't very pretty, but it does keep the cost down. Following the heat pipes down the height of the cooler, we can check out what makes the Hyper 212 Evo a well-known good performer. Beneath the base plate, which we'll check out in a second, is where four heat pipes travel through. They combine to form a flat surface that is in direct contact with the CPU's heat spreader. The heat pipes convert from a circular to a semicircular cross-section, increasing their surface area to the heat spreader, maximizing heat transfer, not unlike the Alessi kettle from 1985. And the base plate itself is an aluminium block with a notch and post to support the X bracket, which we'll check out in a minute. The Hyper 212 Evo comes with a single pre-installed 600 to 1600 RPM fan on the European version, but if you're outside of Europe you'll be getting the full fat 600 to 2000 RPM fan. But I'm not a fan of the finish. In my opinion, in a world of cool matte black components, this has a slightly dated or cheaper glossy plastic look. And to go with the variable speed, it of course has a 4-pin PWM connector, which for some reason is white, probably to cut down on costs. So before we move on to the install, we'll need to check out all the stuff that comes with it. First off, we have a plastic clamshell package containing all the little bits, specifically 4 fan screws, which are actually black on the models you'll buy today, an AMD set of retention bolts, an Intel set of retention bolts, a hex nut to Phillips head adapter, 4 nuts, and a tube of thermal paste, which we won't be using since I want to perform a fair test of all the coolers, and thermal paste would just be another variable. Outside of that package is a second set of brackets to attach a second fan. These are made of the same plastic as the cooler, which will break if you over tighten the screw into the fan. Since I've used these before, they already have the rubber pads attached, which initially come inside the clamshell package. And these clips clamp onto the channel cut out of the 57 fins on the cooler. And finally included is the backplate and X bracket, which supports the sockets shown at the top. Those sockets have been taken directly from the Cooler Master website linked in the video description. If you want to know more about what those asterisks mean, head over there. With all the parts covered, what's the installation process like? Well, just before we get started, the nylon washers on the motherboard are stuck. I tried to take them off, but since I include them on all CPU cooler installations so the motherboard finish doesn't get worn away like it did in this video, they may as well stay on. And don't worry about low pressure on the CPU, since the X bracket has pressure balancing springs to compensate for tolerance. So back to the installation. First off, we need the retention bolts. I'm using the taller ones for the Intel motherboards, and these can be pushed through the holes on the motherboards and left hanging while we go around to the other side of the system. Around the other side, we can offer the backplate up to the bolts. Notice the bolts have a flat side, which makes placing the backplate onto the bolts easier, and they can be turned to temporarily grip the backplate while you're working on the rest of the installation. Next, we can grip the retention bolts with a pair of pliers and return to the back to secure the bolts with the included nuts. I prefer to use a hex nut driver to tighten the nuts down, but you can use the included hex nut to Phillips driver adapter seen earlier to do the same. For some reason I decided to put the nut into the adapter first instead of doing the normal thing, which would be screwing the nut onto the bolt by hand first and then tightening it down with the tool. Anyway, it's worth mentioning to watch out when removing the driver, since the adapter can easily fall off even with a decent magnetic screwdriver, and it could also end up scratching something on the way down. Putting the final two in place rounds up the work from the back of the motherboard, so everything left to do is around the other side. Before installing the cooler, I wanted to go over how the X bracket works. It's designed to be a very versatile bracket to suit many different sockets, hence the moving action. You'll see it interact with the cooler in a second, but I think it helps in this situation to see how it works without the cooler as well. If you look to the center, you'll see what looks like a thumb screw, but it is actually a post to hold a center spring, which doesn't need fiddling with, and the holes around this post are what create the notches for the preset bracket positions. Back to the notch in the base plate we saw earlier. That's where the X bracket's post drops into, and the post of the base plate encourages the prevention of the X bracket rotation during installation. So let's actually install this thing. After laying the motherboard down flat, we can add a touch of thermal paste. I'm going to be using an average Arctic MX2 for all CPU cooler reviews to reduce the variables during comparisons in the future. With the X bracket supported by the cooler base plate, the cooler can be lowered onto the CPU while trying to align the X bracket screws with the retention nuts below. Screwing the screws in evenly at a time is optimal for securing the cooler down to the motherboard. This keeps the thermal paste nice and evenly spread, as well as keeping the forces on the socket and the CPU as even as possible. Once all the screws have been tightened until they come to a sudden stop, we can replace the included fan that was previously attached. You may need to temporarily remove some of the RAM sticks to make this work, but I've been able to use high profile RAM sticks next to the cooler just in case you were thinking of doing that too. Very briefly going over connecting the fan to your motherboard. If you want to guarantee that you can set your fans up with a PWM fan curve, you need to check your motherboard manual and see which fan headers have a PWM compliant setup. You can see in this motherboard's manual that the CPU fan and CPU opt headers have PWM speed control pins, but the other fan headers don't have PWM or speed control pins. However, you can set a CPU fan curve for non-PWM headers in this motherboard's UEFI BIOS, but that might not be available to your specific motherboard. For instance, the MSI Z170M Mortar motherboard this channel uses for case builds doesn't have this ability. So let's check out what she looks like before we perform a Prime 95 small FFTS torture test in this default configuration, and then we'll test it with a higher performance fan and then two higher performance fans to see the limits of this cooler's capability. So here's a result of the fan by itself. Oh god. Okay, I know what you're thinking, I know what you're saying. What the hell, AV? Are you some sort of idiot? Is the cooler really that bad? How did you screw up getting an i7 6700K at 4GHz to go to 90 odd degrees on a Hyper 212 Evo? Is it really that bad? Is the fan that bad? Do you really need more than 1600 RPM to run it? The answer is mostly no to most of those. The idiot part might be relevant. Unfortunately, I had a few issues with trying to get this motherboard set up for CPU testing to make something that was sort of long lasting for lots of CPU cooler reviews in the future. So basically, initial issue was that it was ramping down the multiplier to about 36 times from 40 times, so it reduced the frequency of the CPU, so it would reduce the voltage and reduce the temperatures down to about 60 degrees. It wouldn't allow it to go higher than that. Whenever it did, it would ramp the multiplier down, which meant that was completely pointless. That's technically thermal throttling, but in a really weird way, which actually wasn't potentially going to damage the CPU. I know a lot of people say, oh, 70 degrees and that sort of thing is really going to kill the CPU. It really won't. It's fine. I've had this one running at 90 degrees for pretty much most of the tests in any of the cases that I've been doing, so it's fine. But that was one issue. So I had to try and fix that by locking it off at 4 GHz. stopping the multiplier from being fiddled around with and all that sort of stuff in the BIOS. Managed to do that. Unfortunately, for some reason, the Asus board that I was using was ramping the voltage up way high, and that's probably something to do with the levels, LLC, which was probably sticking up to like a level 7 and throwing the voltage way over to maintain the 4 GHz for some reason or another. So basically I had to go back to the BIOS, disabled everything, disabled the CPU from talking to the voltage regulator and stopping it from being able to tell its temperature and all that sort of crap, but allow the motherboard to detect the temperature and refer that back to the programs I used, so CPU-Z, CPU-Z if you want to call it that way, to determine the temperatures and the voltages. So I had to lock everything off from that point there to stop it from throwing it up to what was originally 1.45 volts. So that was the Asus board was throwing the CPU to maintain that 4 GHz at 1.45 volts, which was horrendous. And obviously that's causing loads of issues, hence why you saw the temperatures you saw just then. So terrible. So I had to stop that from talking to the voltage regulator like I just said, and fiddle around with all sorts of other things. So now it's running at 1.2 volts, but during testing it runs at 1.23 volts, which will take us the marker we're using, so 1.23 volts on a 6700K, which is a 91 watt processor, so take those into account when comparing it to other people's results. And now we can have the proper results, which are these, which you can see now. So that is obviously a lot better, around the 60-degree mark. I can't quite remember what it was, but you'll see them now. So that's the true result of what you get when you have a 6700K at 1.23 volts at 4 GHz, locked at that, no turbo involved with that. That was disabled as well. That will be disabled for all future CPU cooler reviews. So that's your true measurement. So now we can move on to the other types of tests by adding or changing the fan to a high performance one and adding a second high performance fan in. So we're doing 3 tests in total. We'll do that for all the CPU coolers so far. Sorry this is taking up way too much time. I will include the 1.45-ish, 1.43, 1.45-ish volt results as well, just for fun. We're not doing that in the future, but you know, I've got the results, I've got the graphs, I may as well show them. So sorry for this intermittent 3-minute extra time period. Hopefully you enjoy the rest of the video, and I will catch you then. I've sort of run out of words. So let's change that stock fan with a 2200 RPM EK Varda fan. This process of attaching the clips is simply a case of using the included screws, the ones you get will be black and not silver like the ones I have here, and screwing them into the fan like so. Just make sure you get the clips on the correct side of the fan in terms of where you want the fan to be blowing, and in a position so that when the fan is installed, the cable will exit the fan in the right area as per your design intentions. Swapping the fans is super simple as well. You can actually do this when the computer is on, but it's not advised. Note that there is power to the motherboard when I'm doing this now, but the system isn't actually on, as it were. Also, I've never swapped it when the system is live and the fan being swapped is in the CPU fan header position. I actually test these fans on the chassis fan headers at full speed, which you can swap live, but again, I'll say it's not advised because someone will complain. So, kicking the system on, our test results are as follows. We're down on the average CPU temperature by an extreme 0.5 degrees Celsius. Clearly the stock fan is doing a decent job by itself. And here is the 1.45 volt test result, again just for a bit of fun. So is there a decent improvement to be had by adding another Varda fan, so we'll have a push-pull configuration? By the difference between the change in the 1600 and 2200 RPM fans, you can probably see what's coming, but why not test it anyway? So here are the results, and we're looking at an even more minute difference of a 0.08 degrees Celsius. This might make some people really angry because they've been told that push-pull configuration is the best, but how many times have you actually been shown the difference? It's actually really interesting. There are clearly diminishing returns at stake here, but we're actually probably looking at a cooler that really hasn't got the fin density for another fan to make any difference. Thinking about that, if the speed of the air isn't losing much speed through the cooler, then adding another fan isn't going to exponentially increase the speed, it will just maintain it. I gotta say, I love this stuff. And quickly adding to that, why would you have 2 fans on this cooler? Well, the simple answer to that would be by having 2 low RPM fans for a very quiet build. And of course, here's the stupid 1.45 test result, which actually dropped the temperatures by nearly 2 degrees, which of course makes sense since the temperature difference between the cooler and the ambient temperature was larger, which makes cooling more efficient. And just to help you process all those test results better, I thought stringing them together all at the end would help so you can see the gradual drop in temperature. In future videos there will be comparison charts that are already set up to be occupied by the coolers voted on by all of you. Speaking of which, here they all are from the last vote we did a few weeks back. You all voted on ones which I sort of picked a handful of about 8 or 10 of them out. You picked these ones as the most popular ones as of like 2 weeks after the voting. They might have changed a little bit since then, but these are all the ones which you picked. I ordered them all on a Black Friday sale, so I've saved a little bit of money, which helps with the channel. I'll get onto that in a second. The videos for these will be coming out at least intermittently between case reviews. So we've got a couple of ones. We've got a Corsair Air 240. We've got this bit Phoenix something, Aegis. We've got that as well. The box got really damaged on that one on delivery, so hopefully it's okay inside. But yeah, so we've got that one as well. We've also got the Bit Phoenix Colossus, I think. We got that one coming. That'll be in a few weeks' time because it was out of stock, but it was a great price, so I got that one while I could. So these will all be coming intermittently of each other. So we've got the Corsair 240. We've got one of these. Which one would you like to see first out of this stack? So we got the Be Quiet Pure Rock Slim. We got the Cryo Rig M9, and we got the C7 Cryo Rig, and we've also got this Arctic Freezer 11P. Let me know in the comments below which one you want to see first in a couple of weeks' time when we do that one. Hopefully the Corsair 240 will be the next video. I've talked about videos way too much now. So, back onto that point of cost and what these cost and stuff like that. At the moment, this channel is being heavily constrained by this sort of second adpocalypse. Previously, before I was affected by this, my videos were getting things like at least 3,000 views in a month for a video. But now it's been so tightened down and constrained because the last 3 or 4 videos I've done have all been demonetized within the first 24 hours for a period of time, and then they were remonetized. But if you know anything about YouTube videos and view counts and stuff like that, the first 24 hours, 48 hours is what really counts. That really matters. That really helps acceleration and the recommendation and stuff like that. And when a video gets demonetized, which you may have heard recently, that basically throws it out of any suggested content and all that sort of stuff. So I was hoping not to do this so early, but I'm gonna ask you guys about it first. What would you think of me opening a Patreon page to see if anybody would be interested in helping fund the channel's running? Currently I pay for everything out of a full-time job. That's completely fine. This is at the moment a hobby. I would like to turn it into more than just a hobby, a part-time job or even a full-time job in a couple of years time in the future, however long it takes. I'd love to do this full-time, but at the moment it's being funded by a full-time job, so I'm fine with doing that. But because of this adpocalypse stuff, this means that previously where I was getting 3,000 and 6,000 views in a month's video, I'm down to say 300 or 500 views in 1 month. I'm not sure whether it's the content I've covered lately. It could be that. It could be that the content I've covered, the products, the Node 804 and that sort of stuff was not as popular as it should be, but it's had a huge effect from what I can tell. So what would you think about that? Would you personally fund it? Would you think it would be a good idea for those who potentially have the bit of spare money that they can throw somebody's way to help them do a project like this? What do you think? Any comments will be great, so I can get a good gauge of whether it's worth doing at this point, worth holding off on, or shall I just throw it up just to see what happens? So yeah, so that's all I've really got, but I'd like to say and reiterate what I said last video and the video before. A huge thank you to everybody who is still here, who is still around, who are still commenting, liking videos, giving me advice, telling me where I'm going wrong so I can improve videos on a video by video basis and that sort of stuff. So yes, final thoughts on the Cooler Master Masterbox Likely 311. Did that way back. You can check that top right hand corner, by the way. The Cooler Master Hyper 212 Evo. It's a great cooler. It's obviously been around for a long time, and it's obviously going to be around for a long time from now on. It really just performed very well. It performs seriously well with the cooler it has by itself. 600 to 1600 RPM cooler. It's a fantastic package out of the box. It's not it's not the coolest, it's not the cheapest cooler you can get. Obviously there are different ones that are varying prices that compete in the price range, but it does have that direct heat pipe contact that is spread out in a semicircular fashion, which is just nothing that most of these other ones have, most likely down to the fact that it is patented by Cooler Master. So there's potential that that's going to be the king, the big daddy for a long time. So yeah, great cooler. Pick one up if you fancy it. Don't feel too compelled to get more than just this cooler or this fan. Not unless you don't like the glossy look, which I am not a fan of. So yeah, that's it. Sorry I've dragged this on way too long. I do this all the time, and I will hopefully shorten these in the future. So let me know about the next cooler you want to see. Let me know about the cases you want to see. Let me know about the Patreon page. Let me know your thoughts about the video and future videos from this one. Thanks for checking out this one. I'll catch you in the next one. See you then.